In this video, we're going to talk about how we use experiments to produce data. Remember, a response variable measures what happens to the individuals in the study, and an explanatory variable explains or influences the changes that happen in the response variable. So in an experiment, what we're interested in doing is looking at the response of the response variable when we change the explanatory variable. So a little bit of vocabulary that we use. Subjects are just the individuals that we study in an experiment. The factors are another word for the explanatory variables. And a treatment is the experimental condition that we apply to the subjects, the way that we manipulate those explanatory variables in the experiment. And if there are several factors, a treatment is going to be a combination of manipulations of each of the factors, each of the explanatory variables. So here's a case study that looked at the effects of TV advertising. And they were trying to determine the effect of repeated exposure to an advertising message. And they were wondering if saying it may depend on the length and how often that message was repeated. So the subjects, the individuals that they used in this experiment, were a certain number of undergraduate students. And all of the subjects viewed a 40-minute television program that included ads for a digital camera. But they were broken into different treatment groups. So, some of them saw a 30-second commercial and some of them saw a 90-second commercial. And the commercial that they saw was shown either 1 time, 3 times, or 5 times during the program they watched. So that gave us 2 factors, the length of the commercial and the number of times that they saw it. So those 6 combinations are put together by looking at the 3 values of the one factor and the 2 values of the other. So this chart shows you what happened. That if they watched a 30-second commercial, it was either 1 time, 3 times, or 5 times. They watched a 90-second commercial, it was either 1 time, 3 times, or 5 times. And they just numbered the treatment groups based on that. So subjects in treatment 3 saw a 30-second ad 5 times. Subjects in treatment 5 saw a 90-second ad 3 times. And then after viewing it, all of the subjects answered the same questions that had to do with their recall of the ad, their attitude toward the camera, and their intent to purchase it. So those 3 were the response variables, because those are the responses that they were measuring after the treatment was applied. So, in comparative experiments, experiments are going to compare treatments rather than assess the effect of a single one. Okay, and that's what this case study was. It was comparing what happened based on what length of commercial you watched and how many times you watched it. Now, there are problems when you assess a single treatment with no comparison. The conditions may be better or worse than is typical, causing a lack of realism, which is a potential problem really with any experiment. The subjects may not be representative of the population. And there's something called the placebo effect, or the power of suggestion. And we'll talk more about placebo effect. So not only do we want to do comparative experiments for the best data possible, we want to do randomized comparative experiments. So we randomly assign treatments. And they should be applied to similar groups of individuals to remove lurking variables. The assignment of treatments really shouldn't depend on any characteristic of the subjects or any judgment of the experimenter. So best principles to think about. Randomization. You want to randomize to balance out those lurking variables we talked about. A placebo to control for the power of suggestion. And you want to use what's called a control group, somebody who receives no treatment at all, so that you can understand the changes that aren't related to the treatment of interest. So here's another case study about quitting smoking with nicotine patches. So the explanatory variable was the treatment assignment, getting the actual patch. And the response that they were looking at is whether or not people quit smoking. So people either got the treatment of the nicotine patch or they got what's called a control patch. It was a patch that they thought was a nicotine patch, but it wasn't anything. And those were randomly assigned to people. And then they want to look at the cessation of smoking in both the control group and the treatment group. So the placebo in this is the control patch, okay? The placebo is no treatment being applied. You might have heard of the term sugar pills. So sometimes with medication that's in a pill form, people will get what's called a sugar pill, and it's a pill that has no medication in it whatsoever. And the placebo is, some people by just the power of suggestion will, in this case, quit smoking. They think they have a patch on, that's what they need to quit smoking. And so they assume that it's the patch doing the work. And if we have a group that has that control patch, then we can control for that placebo effect. We can see what the rate is of people quitting smoking with just the placebo patch. So in a completely randomized design, all subjects are allocated a treatment at random among all the treatments. And that way we can compare any number of treatments from any number of factors if we do a completely randomized design. When we call an experiment double-blind, that means it's done in such a way that neither the subjects nor the investigators know which treatment they're receiving. So like with the nicotine patch and the control patch, if you don't tell the subjects whether they got a nicotine patch or a control patch put on, and you don't tell the people that are putting them on and doing all the recording, all of the stuff that those experimenters do, you don't tell them which people have the control patch and which people have the nicotine patch. We call that a double-blind experiment because both of them are blind as to what's going on. And we do that to control any level of response bias from either the subject or the experimenter. So here we talked about the case study with the patches. Double-blind meaning that the participants don't know what patch they received, nor do those who measured their smoking behavior. Now sometimes we do something called pairing or blocking to reduce the effect of variation among subjects. And this is different from a completely randomized design where all subjects are allocated at random among the treatments. This time we're doing a little bit of choosing when we assign treatments. A matched pairs design, that's when you're pairing, is comparing two treatments. So you want to match up subjects into pairs that are as closely matched as possible. And then give one treatment to one subject and another treatment to the other subject. The assumption being that if you've matched them really closely, the responses will be extremely similar. And sometimes you're going to do a paired design where it's actually a single subject who is its own pair. They're receiving both treatments, and they're measuring the different effects. And in that case, you have to randomize the order of treatment. So you don't want to give everyone the first treatment and then give everyone the second treatment. You want to randomize which one they get first. That way you minimize the influence of one treatment on another. And a block design, the last one we're going to talk about, it's a group of individuals that are known before the experiment to be similar. And then you randomly assign individuals treatment within each block. Match pairs designs are block designs where the block is 2 people. But you can do it with a block that's larger than 2 people, okay? You could also have a single subject serve as its own block if the subject receives each of the treatments, more than one treatment, in a random order. Okay, so again, you have to randomize the order in which they receive them.